Welcome to the interview of Mr. Wiliam Carlson about his involvement in data storage and semiconductor packaging technologies in multiple companies and the resultant impact of these efforts on the history of computers. Starting during his university studies at UC Berkeley and summer internships at IBM, Bill had a decades-long career working in solving key technical problems in multiple companies, which had significant positive impacts on the evolution of disk drives and semiconductor packages. After IBM, he had assignments at startups like Caelus and CFI Memorex, as well as Maxtor, Seagate, and Tessera. Examples of his contributions in solutions of significant problems range from durability of particulate magnetic disks to adoption of HEPA filters in disk drives to elimination of silicon chip failures caused by traces of radioactive elements in semiconductor packaging materials. So, Bill, we're ready to go.
Okay.
Why don't you first tell us a bit about your family background? Where were you born? Where did you grow up? And your education?
I was born 1939, August 22nd, so I just turned 86 last month. But I grew up in small towns of Healdsburg and Santa Rosa, California. My dad had inherited some downtown property in Healdsburg, so we lived there through about the 6th grade, I think. Really enjoyed Healdsburg. It was a nice little hometown. And then we moved to Santa Rosa, and I graduated in 1957 from Santa Rosa High School. And right next door was Santa Rosa Junior College, one of the community colleges. And so I went there for 2 years and graduated in 1969, I guess it was. Then 1959. And then off to UC Berkeley. And in those days, if you got a B average or better in the community college, you're automatically enrolled. So I went to Berkeley, and a lot of my friends from high school and junior college were there as well. So I thoroughly enjoyed my time at Berkeley. It was a big change from a rural Santa Rosa to an urban center, but I had a lot of fun there. I worked in summers for the physics department, and I was a gopher. I would punch cards on a keyboard punch machine and take them up to the rad lab where they had a big computer. And so I got to see a lot of stuff. Got to see the Bevatron. A friend of mine worked there. And in those days, Berkeley was a hotbed of nuclear science, so that was a fun place to be. And then in 1961, I think it was, I was a junior and looking around for something to do in the summer. And I was over at Palo Alto because I wanted to hang out with a friend of mine who was going to Stanford. And there was no work there. I went to several little companies, but one of the guys recommended IBM as a possibility. So next day, I hot-footed over to IBM and went to the personnel department. A guy named Jim Slaughter was there, and he took my resume, and I had a grade slip, which is not too bad, and filled out the forms, and I got a call in a day or so that I was hired. So my first job at IBM, working for John Del Favreau, who was manager of the manufacturing division, and I was researching magnetic materials, coating formulations, in hopes of making some improvements to the coating formulation. There was nobody else working on it. The guy who invented it, Marcel Vogel, had gone on to other things in research, and the other fellow, can't remember his name right now, was not involved anymore. So I was kind of the only one, and that was a fun summer. I spent the time in Building 25, the research building, and met Marcel Vogel, who was a very interesting guy. He told me the fine points of the coating formulation, and did a lot of research on magnetic materials and tape, which was a precursor, of course, to magnetic disc. And they had a Xerox 914 machine there, one of the first ones, and that was a wonderful thing. I could copy journal articles and stuff. So I spent that first summer basically in research. I wrote a paper, made some recommendations to add some cobalt and magnesium to the iron oxide for better performance. I guess they liked what they saw because they invited me to come back second summer, which is unusual. And so I did that, and that second summer was spent doing experiments. So we made different oxides, tried them out, and nothing was spectacularly better than normal acicular iron oxide, but we did a lot of work on that. And then after that summer, they hired me full time, so I became a beginning engineer at IBM. And the IBM experience was wonderful. It's a great place to start a career. They had free reign of the whole place. They trusted you implicitly. These were long before the days of corporate espionage and the disk drives. So it was fun. I had the run of the place and met a lot of nice people, including Al Shugart and some of the people who later became kind of famous.
Very interesting. Can you recall who are some of the people who most influenced you growing up?
Yeah, probably the most noteworthy one was a guy named Claire Elmore, and he taught science at Santa Rosa High School. And he was well known as being an excellent teacher. And so we learned experimentation. In those days, we were playing with mercury. Today, they put it in the next room, but we were playing with mercury and doing all kinds of things, which today might not be very acceptable. But he was an inspiration, a very good guy. And in junior college, the math teacher was quite good. The chemistry teacher was quite good. The physics guy was not so good. He was an older fellow and had nothing to do with modern physics. It was all old stuff. But I loved physics, and so I went into Berkeley with a physics major.
Very interesting. Did you have an early idea of what you wanted to be when you grew up?
Well, I was always interested in mechanical things and scientific things. When we were kids, we used to take apart various things and put them back together. I made nitroglycerin, a little dangerous, but we made it and it worked. We made fireworks. Some friends of mine and I built rockets, and so we launched rockets at a dairy ranch owned by the parents of one of my friends. So I was interested in photography, and my dad thought I might pursue that as a career, so he took me around to some places that might do that. But by that time, I was interested in electronics as well, and so I kind of focused on that. Those were the tube days before transistors, so I built tube amplifiers from kits and from scratch, and won an award in a science fair for an electronic experiment where I grew a crystal and made a microphone out of it, Rochelle salt. But I guess my dad was an inspiration as well. He could do almost anything. He was a real estate broker, but a carpenter by trade, and he built 2 houses, and I helped on the second house.
And is that are those hobbies the ones that inspired you to then want to pursue a career in engineering and science?
Well, I always wanted to do science. I wound up, as I said, going to Berkeley, thinking to major in physics, and I love physics. I love the concepts, how the universe is put together and stuff. So I like that, but I didn't care for much for the advanced math. And my advisors kept sticking me in math course I didn't care for. So in the end, I wound up deciding to switch to chemistry, which was equally scientific in my view, but it was more practical, more hands-on. And the College of Chemistry was fun. It was a smaller things and letters and science at Berkeley. A very friendly staff and a lot of nice students, and I was in a science chemistry club, went on conferences and had a good time at Berkeley.
And you weren't happy with just a bachelor's degree. What led you to want to go to graduate school?
Well, I always did want to go to graduate school. And at one time at IBM, they were going to open a facility in Boulder, Colorado. And so I drove over there, and I was going to enroll at University of Colorado for a PhD, but I didn't like Colorado that much, and I didn't like the snow, and it was going to be far away from my friends. So what I did is at IBM, I got a master's at San Jose State, which is nearby, and that was done in 2 years. And my thesis advisor was also a co-worker at IBM, which made life easy. And the secretary in our department typed up my thesis, which is nice. So IBM was a wonderful experience.
And
well, you mentioned the thesis. The thesis project was electrophoresis of carbon blacks and benzene, which sounds very esoteric. The idea is IBM was interested in making an office copier. They missed the boat on Xerox machines, which had been offered to IBM by Chester Carlson, the inventor, but they turned it down. And they said, who needs an electric copier? We got carbon paper. So they then realized the errors of their ways and launched a program. Dr. Schaffert ran it in ASDD. And so we were looking at the toner aspect. They couldn't use dry toner because that was patented by Xerox. So we're going to use a liquid toner. And so I studied that along with my thesis advisor. In the end, I thought it was very impractical. You know, benzene is poisonous and very flammable. I couldn't imagine how you would make a machine that used that. But it was never a success at IBM. They never produced a machine. But I got a thesis out of it.
Well, it's very interesting. If you think back about the IBM experience, what were some of your winners and which were some of your losers in terms of your projects?
That's fun. I really enjoyed IBM, as I said before. Some of the winning projects, we made our own coating in the Building 13 development lab. And we had a little ball mill, 32-gallon ball mill. And you would add the sodium, or the epoxy, EPON 2004, or 1004, I think it was. And then the R108 and PVME and all the ingredients. And we'd mix up a batch of coating, and then we would coat disc, and it worked fine, but it wasn't very durable. And the durability test was interesting. We called it a tap-tap tester. And the idea was that a head would load on the disc in a kind of a slap fashion. And you had to be durable enough to have many head loads without breaking through the coating. So this tap-tap machine was a cylindrical stainless steel rod curved at the end, and it would poke into the disc while it was rotating. And I think the force was about 300 grams, kind of similar to a head. And then they would count the number of taps that it would make before it broke through the coating. And when it broke through the coating, it would touch the metal disc and complete a circuit and stop the test. So our coating was not very good compared to the production coating. So I took some of our coating over to the manufacturing lab, Ed Ketman, in Building 5, and they analyzed our coating. They said, well, it's the same. The exception is that the coating from manufacturing had a little bit of white residue left over. I said, what is it? Well, we don't know. Okay, well, why don't you give me some of that? So I took a whole bunch of test tubes of that white residue, added it to our coating in the lab, and voila, now we had durability. So apparently what was going on is this white material was ball mill debris that was small enough not to be filtered out by all the filtering that they did. And it imparted a degree of durability to it, similar to rocks in concrete, I guess. It provided a hard surface. And it turned out we reinvented the wheel because the tape people had figured that out in early days of tape. And they typically add a certain percentage of aluminum oxide or some other abrasive to the tape formulation. When I was at Memorex, I asked an IBM FE who was in changing heads in one of our tape drives. I asked him, well, why do you have to change the head? He said, well, because there's an abrasive in the tapes that wear out the heads. And he said some are better than others. The worst was Graham tape. They called it Old Gritty. And so anyway, we had reinvented something that the tape guys already knew about. But that led to a patent. My discovery work was then used by Joe Hafel and Ron Kubek after I left to get a patent on that subject. Another interesting one was particle alignment. It turned out that in tape, when the tape is wet, you have the opportunity to align the individual particles in the best direction for communication with the head. You want to have the long dimension of the particle in the gap dimension. So, of course, with a rotating disk, that's not possible. If you tried to well, you couldn't easily do it. And I came up with a solution. We got some magnetic disk brakes from the 2311 program, and we put them underneath and above the disk and energized the magnets to provide a field in the circumferential direction, rotated the disk while it was wet, and you could see a difference. It became iridescent. And so we cured the disk and handed it over to the engineering people to evaluate. And it turned out there was sufficient advantage that that was adopted on the 3330 Mod 2. So ever since then, disks have been oriented, and I had the pleasure of having introduced that. What else did we do? Oh, the HEPA filter thing. Turns out that an FE had taken 2311 heads out of drives near the San Jose airport, the facility there, and during routine maintenance. And he noticed that there were kind of a translucent, grayish, brownish stringer after the head, the trailing edge of the head. He didn't know what it was. He said it didn't affect the machine operation, but he thought it was unusual. So took it to development lab. It was analyzed by Irma Barlow in the chem lab. And she said, hey, it's interesting. That's the same kind of fingerprint as I see in reports on air pollution. And, oh, that's interesting. So maybe somehow the head flight dynamics were collecting debris in the trailing edge. And so we thought, well, that's worth experimenting. So it turned out cigarette smoke was similar to air pollution. I guess it is a form of air pollution. So I had a box built over a spin stand, and we had a technician, John Ramos, smoke cigarettes into this chamber. It's a very stinky process. And one day I mentioned to John, he was busy smoking a cigarette while he was pumping smoke into this box. He says, John, didn't you learn something from this? This stinks. And he says, yeah, but I have a filter cigarette. So anyway, we did that, and we couldn't make this fail with just cigarette smoke. Then someone suggested, well, let's try some airborne contamination, particulate stuff. And there's something you can buy called Arizona road dust, which is a highly graded material, very fine powder. And we fed some of that into the machine, and that didn't fail either. But when we mixed the two, we put in the aerosol from the cigarettes and a little bit of this dirt, then head crash started. So we had demonstrated that you could fail. The filters in the drives in those days was a little paper filter. They said it came out of a Ford Falcon. I don't know for sure. But Mill Call, he ran product test. He came over and we talked about it. And he said, hey, I'm going to scale up this experiment in product test. So he took a closet and put a whole drive in there and smoked lots of cigarettes out the drive and did some dirt. And anyway, the result was that it was deemed that the aerosols were getting through the paper filters, and we went to a HEPA filter. And so that was adopted on 3330. And ever since, I think, they've had HEPA filters. So that was fun. What else did we do?
Well, if I could just stop you, it seems to me the magnetic particle orientation must have improved the signal-to-noise ratio of the media, right?
I'm sure it did. I never
people liked it.
I never saw the hard data, but if you align the particle into the gap, then that should have maximum communication between the particle and the head. So I'm sure it helped. Otherwise, it would be random, and you wouldn't see a good signal-to-noise ratio.
And it seems like the HEPA filter was fundamental, right? Because disk drives have this unique characteristic of having to fly these heads very close to the disk, right? So any contaminant that would build up anywhere at that interface could be catastrophic, right? So I thought the HEPA filter was a great innovation, right?
Mm-hmm. Yeah, the HEPA filter, I believe the spec was 99% of anything 0.5 micron or bigger. And it turned out that it would catch things that were smaller than the head flying height. So it was a good solution, and it was implemented after that.
I think, if I'm not mistaken, all subsequent disk drives had sophisticated filters in one form or another, right?
Yeah.
Even to this day, they have to do that. So that was quite a breakthrough.
That was an interesting project. What else was interesting? I had some other stuff in there.
You worked on substrates too?
Yes, that was an interesting thing. It turned out that I wrote the disk spec for the 2314, and after that we were working on the 3330, and I noticed that the tally-surf traces, the profilometer of the disk towards the outside edge, had a concave feature. We called it a ski jump, and it was shallow enough so that the high flying heads like the 2314, it wasn't affected. But the 3330 was a smaller, lower flying height head, and so we thought it might hit the edges of this contour. So there wasn't much that could be done with that current substrate polishing method. They had a device in Building 5 called the Autotran, built by Phil Kimball, Scoop Kimball we called him. And it was a carousel affair. And it had a series of brushes and then slurries of various abrasives going from coarse to fine. And you wound up with a very shiny, good-looking disc to coat. And so, unfortunately, though, it had this little ski jump thing that was going to not work too well for the 3330. So it turned out, kind of by accident, we had a visitor from IBM Germany, a guy named Fred Severin. I don't know his role. I think he was a plant manager, possibly. And so we showed him the traces and the fact that we're on this new program, we're going to have troubles with the disk. And he says, we don't have those problems. He said, why not? Because we don't polish that way. We diamond turn. We use a lathe cut. And, oh, okay, can you give us a sample? And so a few weeks later, a skid of substrate showed up, and we gave them to manufacturing, and they coated them and polished them. They loved them. They said, hey, this is the way to go. So they shut down the Autotran, and they canceled the Autotran number 2 that Scoop had almost finished, and went from diamond turning ever since. And I think that's, for aluminum disc, that was the only way the discs were made after that. So that was a substrate thing. What else?
You also, I think, as I recall, tried your hand at in projects related to plating of materials?
Yeah. The back end of Building 13 was full of our development stuff. We had Dwight Breda doing development on heads. George Santana was doing the channel work, and then Ron Kubik and I were doing the disc coating. And then we all reported to Ray Herrera, who reported to Al Shugart. So that was the chain of command, and so we got to know all those people. The plated disc was next to our coating lab, run by a guy named Ignatius Su, TSU, and his tech was Jerry Leary, who I became very friendly with. And they tried to plate disks. The only method used by IBM in those days was electroplating. And they had a nickel cobalt bath. They could make a nice magnetic disk, but it had two problems. One was that it was not corrosion resistant sufficiently. The other is mechanical durability. If you slap a metal head on a metal surface, you get galling. And so that was a problem. Now, we're able to fix the corrosion issue. I read in the literature that you can do something called a chromate conversion coating. And the idea is you dip a disk into potassium chromate or dichromate, and it forms a layer on the surface, reacts with the surface layer, and makes an insoluble protective film. And so we tried that, and sure enough, the corrosion problem was gone. The problem was we still had the durability problem because the coating made by the dichromate bath was somewhat soft. It was not hard, and it was not durable when you slap a head on it, on a disc. So that didn't work. Then they tried plating with hard chrome, and that also had the galling problem. Again, metal on metal is not a good solution. So that was before the days of sputter coating with carbon. So essentially, the plated disc was not successful at IBM. Then we tried plated drums. Ray Herrera had a passion for making a high-speed drum. I'm not sure what the application was. It might have been a buffer or something. I don't know. But he wanted to make this thing. And so what we did is Bob Bajorek, who was my office partner at IBM, he supervised making the drum. It was copper-plated and was class 7 bearing, so it was almost zero run-out. And it was highly finished by the model shop. And then it was put in looked like a child's coffin and to protect it. And I took it to Endicott. So I flew to New York and drove up to Endicott, and they plated it for us. The guys in San Jose couldn't fixture a drum. They were all set up for discs, and so it was easier and faster just to ship it to Endicott and bring it back. So I took it out to Endicott, met the guys there. They had an interesting way of plating called periodic reverse. And it was sort of a modified sine wave. On the plus side, you would plate. And on the minus side, you deplate. I said, well, why do you do that? I said, well, you deplate is much less than the plate, and you knock off the asperities because it's chemical polishing. Oh, that's interesting, electrical polishing. So anyway, we got the disc plated, took it back to San Jose, set it up in our coating lab, and Ray was there. He wanted to see this. And it was a fixed head affair. So it had a number of heads, like 10 or 20 heads, across the surface of the drum, and they were supposed to be flying heads. That was going to be the big deal, because conventional drum technology has the heads in a fixed distance above the surface. Ours were going to fly, but they didn't fly too well. They crashed. And so IBM had never done a curved head on a curved drum surface before, and it probably would have worked had they developed it more, but the first experiment out of the box didn't work too well. So that was a bummer. What else? We tried glass substrates. We bought discs from Corning Glass, and they were tempered glass with chemical tempering, where you convert the surface from sodium to potassium by dipping it in a hot salt bath. And they were very durable. You could throw them on the floor and they wouldn't break. And they were coated, and they worked just fine. The problem was Ron Kubik had just reduced the cost of the disc pack to under $100, and throwing $10 substrates into this would screw up the economics. So glass discs were not successful technically. It was just that they didn't make economic sense. So we didn't do that.
Did you try some of the plating methods on tape too, or
some of the lubricants?
The plating. When you did the plating experiments on discs and drums, did you also extend that to tape? magnetic
Oh, well,
tape?
yeah, there was a program called Hypertape. Again, that was another New York thing. The guys in Poughkeepsie had come up with a technique of making a metallic tape, and it was done through reduction of a nickel salt by sodium hypophosphite, a strong reducer. And in the presence of a catalyst, it would turn the nickel ions into solid nickel. And so they had done that experimentally and said, hey, this is an interesting possibility for production tape. Very high efficiency because it's metal, not a coating. And so I was sent to Poughkeepsie to take a look at that, being a chemical guy. And so we looked at the process, talked to the guys, we ran some experiments. In the end, it looked like it was not, and there's a reason they had San Jose looking at it, because San Jose was already manufacturing magnetic material, and so we were a potential site to manufacture this tape. But in the end, it didn't look terribly practical. The magnetic performance was uneven across the tape, and it required unstable chemicals and catalysts, and then you had to monitor the concentration of nickel, and you had to get rid of the bath when you had too much of the decomposition product from the sodium hypophosphite. So it didn't seem like it was going to be a very successful long-term production item. That same technique, the electroless plating, was tried in disk many years later, and it also didn't meet a good end. It had similar problems.
Yeah, I think they suffered the absence of sputtered carbon, right? They also
Comac did that.
They were before their time, right?
Yeah, that's right, exactly. Yeah. Had we had the sputtered carbon, it would have been probably would have worked. And IBM did eventually make a sputtered carbon 5 1/4" disk. When I was at Toshiba, Wendy Duell from IBM was trying to sell us disks made at IBM. They were sputtering them. What else at IBM? I mentioned the attempt at making an office copier, and that didn't work out. We looked at lubricants for the disk. That was done largely in Dwight Brada's lab. And they tried all kinds of waxes and greases and things like that. The best that worked was oleic acid, which is a constituent of things like olive oil. And it did a wonderful job. You couldn't crash your head with this stuff. The problem was that it had a vapor pressure and it would evaporate in a few days. So that didn't work out too well. And I think they were looking at, and so we never had a lubricator disk in all the programs I worked on up through 30. But I believe the Winchester was probably lubricated. No, they were evaluating before I left fluorocarbon lubes, which became a standard later on.
So that was introduced with the Winchester drive.
I think it was. I didn't work on the Winchester. The head design, actually the Winchester was kind of a fun project. We had in our lab a single disk drive made by somebody else, and it used a plated medium, and it had a triangular head, 3 little points, little sapphire buttons, and then the read-write element was on one of the buttons. And it was sold commercially for the instant playback in TV. So they would constantly record the last 30 seconds, and then if something exciting happened in the ball game, they could replay it. And so we looked at that, and it was a start-stop in contact. It was a pre-Winchester thing. And but like Warner said, it was not manufacturable the way it was delivered to us. It was a one-of-a-kind type of thing. Small volume. So he redesigned the head to make it high production, and so that became the Winchester.
The Winchester head. Any other projects at IBM before you flew the coop, before you left?
Let's see, we talked about disk lube, we talked about substrates.
Floppy disk, did you have any
the floppy disk project. It turned out that in order to boot up the computer, you had to have some kind of a fixed memory that would light things up. And they used something called truss tapes. They made them in Building 5, and it was a screwy affair. They would take ribbon cable, punch holes in it, and then drape these punched ribbon cables over studs that would stick up through the holes, and it was back and forth, and you'd get this layered thing. And I'm not sure how it all worked, but that was the boot device. But it was costly. It was labor intensive, and so the decision was made: let's make a little tiny disk drive and boot up the machine that way. And so the idea, I think it was Ralph Flores working on it over in Building 14, but we were asked, "Can you make us a disk?" They couldn't use conventional tape because it was oriented in one direction, and so you'd be oriented and disoriented as you rotated it around. So that wasn't going to be suitable. So in the lab, our tech, Herb Pugh, started to coat mylar sheets. And at first it was hard to do because the coating weight would deflect the mylar, and it would be hard to coat evenly. So he tied little fishing weights all around the edge of this disc, and he finally got something coated. But then to cure it, our disc coating was cured at a few hundred degrees, and that was not good for mylar. So it wrinkled up the mylar. And so in the end, it was a failure. And what IBM eventually did is they got a tape manufacturer to turn off the orientation and sell some tape unoriented style and cut it into circles and made floppy disks out of it.
Interesting. I didn't know how they originated. You filled in a key historical detail, right? How floppy disks evolved.
Interesting project. I guess the first one was 8-inch, and then it went to 5-inch, and then of course the whole floppy thing took off like crazy when personal computers came along. So
it sounds like you were having a ball, right, at IBM?
Oh, absolutely. So, it was heaven for a young engineer who liked technology and got to play around with physics, chemistry, electronics, and all my favorite things. So it was a wonderful experience, and the people there were so good, so nice. I never met an unfriendly person at IBM. I'm sure there was one somewhere.
So what led you to leave, to change companies?
They'd had some departures. The so-called Dirty Dozen left and went somewhere to Memorex, I think, Al Shugart and his gang. And then it turns out Phil Iaconelli, ex-Ampex, had recruited the IBM people who were into disk manufacturing. Bill Souza was manufacturing manager for making disks in Building 5, and Bob Deerdorf was my office partner. He was very familiar with disks. And so they were recruited to join this new company. And the idea was that there was a huge demand for disk packs. IBM couldn't make them fast enough. And so there was a shortage. IBM, I think the price, they leased everything, but the price if you wanted to buy it was like $600, and it cost $100 to make. So it's a very profitable item for IBM. And so there was competition then with Caelus and other people. Memorex got into it, and other companies. So I was invited to join my ex-IBM friends at Caelus, which I did in 1968. And we had a good run for 5 or 6 years, and we made a lot of media. We sold at OEM as well. I went to Japan. We were selling discs to Hitachi, but we're making discs for our own leasing. And the problem with leasing is that you have to spend, maybe $150 to build the disk pack. Then you only get like $10 a month when you lease it. So it requires a big influx of cash to build up an inventory of lease material. And Caelus eventually had financial problems and couldn't do that. So the main investor in Caelus, Electronic Memories and Magnetics, bought us out and took over the company and kept the staff. Most of the staff stayed for a while. A guy named Dick Spriggle was running electronic memories. They made cores for core storage, and they had a company called Indiana General that made other kinds of magnetics. So they were very into magnetic materials. And so I met Dick Spriggle, and he made me marketing manager of all things. He said, well, you know the customers, and you're good at talking to people. So I did that for almost a year. And then the same Caelus crew got recruited by CFI. A guy named, am I getting ahead of the script?
No, you're...
So the whole crew, Tom Skolton, Bruce Colgrove, myself, and some others, were recruited by CFI to do disk manufacturing in Anaheim. It turns out the guy named Bill Lenartz ran it, and he bought a factory that RCA had built. RCA wanted to get into the disk pack business, but they decided it was a bad idea after they built the factory. And so Bill bought it at a bargain and moved to Anaheim and hired all these ex-IBM, ex-Caelus guys to run it. And so we were very successful. We were the biggest producer of cartridges, 5440s, and the front loaders, the 2315s. And so that was very successful, and I was the engineering VP down there, and we built disk packs through 3330 and built a server writer and so on. So that was a lot of fun. And then one day, then I got married while I was down there and had 2 kids, so that added a little to the spice. Then one day, Bruce Colgrove, close friend, he said, hey, something's going on. A guy named George Bragg, who's in charge of acquisitions at Memorex, is talking to our president. And I'm thinking there's something going on. Sure enough, it was announced later that Memorex was going to buy us, and that would make them the undisputed leader in disk cartridges. And so Bob Wilson, who was running Memorex at the time, he was a turnaround expert that Bank of America had hired to solve Memerex's financial problems. He came down and interviewed all of us. He was a very nice guy. And we didn't talk technical. He was grousing about the fact that Santa Clara made him put hot water in the bathrooms. He didn't think that was necessary. So anyway, he was a good guy. And I was offered the opportunity to come back to Northern California, to Santa Clara, which I did. And so I worked at Memorex after that. I was the technical advisor of Computer Media Group, which was tapes and discs. And so I worked for Bruce Colgrove initially. And then other people took over. Wade Meyercord became the leader of that group, and worked for him for a while. And I had noticed over in the disk factory that they were using little Apple II computers for spreadsheet analysis. I said, that's pretty slick. Having prepared my tax return and with spreadsheets, I thought that'd be neat to do that. And I mentioned that to Wade Meyercord, and he said, hey, why don't you get us each a computer? So I knew a guy, John Scott, at Memorex, ex-Memorex, who's at Apple, and we bought 2 Apple consoles and 4 floppy drives. The floppy drives were $600 each in those days. It's incredible. But that's what it was. And so we bought those Apple machines, and I had one at home, and that was my first experience with a personal computer. So what else at Memorex?
While you were at CFI, who was your bigger customer? Was Burroughs one of
Burroughs is the biggest customer. A guy named Chuck Quillen was our star salesman. He could sell anything. And I forgot the guy. There was a fellow from Burroughs who would come out all the time and talk to us. But Burroughs was by far the biggest customer. And we're wondering, where do all these cartridges go? And it turned out that many sites had dozens of cartridges. And in the case of the military said, hey, I know my data is safe when it's in my desk in my cartridge. So it was a way of partitioning data, and the accountants used it to have each client have his own cartridge. So the numbers of cartridges were enormous, and so we produced a lot of those things. But Burroughs was by far the biggest customer.
You said you took one of those Apple computers home.
Yeah.
Early. Did one of your daughters work on it?
Yeah. Well, it turned out that we were in Los Gatos by then. I had moved from Southern California to Los Gatos, and we set up the little Apple in an office area. And my daughter, my youngest daughter, she really liked that. She was playing games on this thing, and before the internet, there were sort of Facebook things where you could talk to people online. And I did banking online, and I had Charles Schwab account. I bought stocks and stuff. So the little Apple was really nice. And then eventually I switched to an IBM machine, which is more powerful. But that was fun.
And do you also work for test equipment makers?
Yeah, that was after Memorex. So I was at Memorex for a number of years, and my last task at Memorex was to write a business plan for 5 1/4 inch media. They had made 14 inch, but never had done 5 1/4. So I did that. I wrote up a business plan. I talked to the finance people and to all the engineers, and we came up with a budget to do it. And then the big day came. We presented the plan to Clancy Spangle, who was I think he was a Burroughs guy. He was now in charge of Memorex, and so we presented the plan to him, and the finance guys all agreed. They said, "Oh yeah, that's right." And then somebody says, "Hey, wait a minute, we should study this some more for a couple of weeks." Clancy Spangle says, "Give the kid the money and let's get on with it." So we got funded, and about that time I took off and left for MTS.
What did MTS do?
Well, MTS was interesting. In those days, the way to test a disk was to have a certifier, and the idea was you would have a single disk stand with a head or a pair of heads, and you would check the disk out and look for defects, and then you'd know what to do with the disk, whether it was good or bad. By the way, at IBM, when they did a similar thing, and they put a little dent on the edge of the disk to indicate where the defect was, so that you put that in the index gap when the drive was built, or when the disk pack was built. So that's interesting. Anyway, so two fellows had founded this company. One guy was ex-Memorex, and he was the one who had built the Memorex certifiers, so he knew that trade inside and out. He was a genius, and he was a mechanical guy, an electrical guy, programmer, and so he was very good technically. And then his partner was Tom Ferrara, who was a Siemens server writer sales guy, and he was excellent at what he did. The problem is the two didn't get along, and so they wanted someone to run the thing and kind of referee those two guys, and that was my job. So I was made the president of MTS, and it was very successful for quite a few years, and until consolidation started. And as with every company like cars and disk packs and computers, it started to shrink. Ampex had a big field failure problem with their ALAR disk, which I believe was a electroless nickel one. And HP bought a certifier from us, but never went into production. It was up in Boise, and so we sold a lot of certifiers. But then, as things started to slow down, we were wondering what to do. We were kind of a one-trick pony. We had this big fancy machine that would test disks, but we didn't have an extensive product line. And then the competition showed up. John Scott had something called a Delphi, and it was a little desktop tester, El Cheapo thing, used an Apple computer and it tested the disk. It was not as fancy or as good as ours, but it was cheap. And so we had competition, and we had a shrinking customer base. And so in the end, we said, well, this is not a good situation. And a friend of mine, another Caelus friend, Hal Soul, was running a company called ProQuip, and they made similar equipment, but bigger than us, about twice our size. And so we merged with those guys. And so rather than two struggling companies, we had one company. So I worked there for a little while, and they didn't need two executives, so I left after a while.
And what did you do after that?
You got the timeline there. I think from after...
was it a disk drive maker, perhaps?
That was, I think it was Maxtor.
Yeah, I think so. I remember you talking about your experience at Maxtor.
Yeah, I was somewhere in there in 1990 to 92, we built a house. And so I took a summer off and was wound up building houses, our house, which was a very successful project. That's a fun story, too. And when I went to work at Connor, all he wanted to hear about was how to build a house. So what we did is we took a course at West Valley College from something called the Owner Builder Center, headquartered in Berkeley. And the instructor would talk about one topic each week, framing, foundations, roofing, electrical, plumbing, all that kind of stuff. And so we decided at the end, we didn't have the time or the interest to do all those things. So we hired the instructor, and he became our contractor. But he said, you got to do some of the work. And we did. I put in the HVAC ducting and so on. And my wife and I did some of the wiring, the outlets and that kind of stuff. So 2 years later, we moved into our house in 1992, and we're still there. So it was a great experience, a nice house.
That's in the Almaden Valley?
Yes,
right?
Yes. It's on a hilltop. An old college roommate of mine, a fellow named Axel Jones, and he was a teacher at the local high school in tennis and history. And we're friends, and he said, hey, I've just bought some property in Almaden, and there's another parcel next to me that looks really nice. You should come see. So we did, and it was a 25-acre hilltop. And so we bought it. It was $200,000 in those days, which is a lot of money then, not as much now, and decided that someday we'd build a house, and didn't have the cash to do it at that time. Later on, my wife had worked for a design firm, a Steinberg group in San Jose, so she was into house design stuff. And so she did some preliminary designs, and then we had to hire an official recognized designer to submit plans. So we hired somebody named Lynn Miller, and she got the plans approved, and then our contractor and we built this house. It was all done with contract out stuff. You don't do everything yourself. We had roofers come, and we had plumbers come, and we had drywall guys. It was an interesting project. I would not do it again right now at my age, but at that time it was fun.
Where was the parcel located? Where is it located?
It's
Valley. Can you localize it?
Yeah, it's between Blossom Valley and Almaden Valley on the hill, in the Almaden Hills. And so we're only about a half mile from Oak Ridge Mall, and then on the other side, the local post office and so on. So it's the best of all worlds. It's rural, and yet it's in the city. So we're in the county, technically, so we don't get to vote for San Jose mayor or any of that kind of stuff. But
and you still have all 25 acres around you?
Yes.
Oh, that's wonderful.
Well, the problem is it's a hilltop, so the slopes getting up to the top of the hill are too much for much use, and there's a big high voltage power line going through part of it, the lower part. So we built the home on the nicest part, about 4 acres buildable, and so we have a pool. And when we put the pool in, the inspector said, "Hey, you got to have a fence around the pool." Oh my God! Okay, that's the code. So where does the fence have to be? We don't care as long as it's around the pool. So we built a fence around the whole property, and that was our pool fence.
So the house is the pool house, right?
Well, we built a little pool house next to the pool.
I know.
We did that too. And we have a basement, which is unusual. I like basements, so we built a basement. Anyway, that was a very interesting project. Malcolm McLeod was our instructor and contractor. And he hired very good people. We had excellent time. So I think the next real job is Maxtor.
Do you recall the highlights of your your Maxtor time?
Yeah, I was hired. I think a recruiter must have gotten me to Mike Warner. Mike Warner invited me for dinner one time, and so we went out and we chatted, and he wound up offering me a job as director of heads and media for Maxtor. So I took the job, and it was fun. His model was to have all the experts in one department, and then we would loan out these people to the various projects. So instead of the 3.5 group and the Panther group, which is 5.25, and some other group, each hiring experts in heads and media, there would be one group with heads and media, and then we would assign the people out to those projects. So I was in charge of that, and in charge of media was Ron Dennison, and in charge of heads was Jack Osborne, both experts in their fields. And we had some good engineers, Jay Kimmel and so on. So that was a lot of fun. And our job was not to manage the ongoing selections of vendors. They were already had a contract with Comag for discs, and they had 2 contracts with 2 Japanese firms for heads. So our focus was on new stuff. So we looked at Senstor, vertical recording heads and media. We built a drive out of that, and it worked okay, nothing spectacular. We looked at glass discs from Nippon Sheet Glass and got some discs in from those guys. And we looked at read-write for thin film heads. And Domain was starting to make sputtered discs, and so we were interested in looking at them. Domain was an interesting company. It was eventually bought by Connor, but they had something called the mint machine because they're going to make a mint on this thing. And they hired guys who were doing sputtering on big, large window glass things, 3 feet by 4 feet types of glass. And so they thought they would sputter dozens of discs at one time. And they built all the machinery themselves. They knew how to do that. It turned out that making discs in a mass way like that didn't work out, and they wound up making them one at a time like everybody else. But it was an interesting affair, and when I was at Maxtor, we looked at those guys. And what else did we do? There were alternative discs being produced using different technologies. Electroless plating was not uncommon in those days. So Maxtor was a lot of fun. One day, Mike Warner says, "Hey, we're going to go look at 2 acquisitions." And what are they? Well, one was Miniscribe. Miniscribe had gone bankrupt. And my old boss, Ron Kubek, had worked at Miniscribe, and he gave me the lowdown on how Miniscribe had been managed. And he said it was fun, but it was very stressful. They would have something called dash meetings, and this guy, QT Wells, out of Southern California, was running Miniscribe. And each division would have to stand up and give a presentation. And if he didn't like the presentation, he would be fired on the spot and rotate some other guy in as the new boss. So these are very stressful meetings, according to Ron Kubek. The guys were not fired who were taken out of the responsibility. They were put into a penalty box to be recycled into some other project. But anyway, they got a reputation of shipping bricks and all that kind of stuff. I'm not sure they ever did that, but they wound up in financial trouble and went bankrupt. So our job at Maxtor was to evaluate and see if they had something worthwhile there. And we looked at them, and there was another company, a smaller company that was higher tech, but not in production. And we liked Miniscribe. So the recommendation that was made by Mike and the group was Miniscribe was the better bet. And Tarun Kamdar, who was the marketing guy at Maxtor at the time, he said, "Good, let's do it." So they bought Miniscribe. Getting back from Colorado was a challenge, it turned out. That was October 19th, I think it was, 1989, the Loma Prieta earthquake hit. And so there we were sitting in the airport, and all the news was that California was being destroyed by an earthquake. And so we sat in the lounge and saw Santa Cruz, being leveled and bridges falling down and San Francisco having problems. And I tried to call my wife, and I couldn't because the phone lines were all down. So we were convinced San Jose had been leveled. But it was just the news media. They like to show the ugly stuff. And so we finally got out of town the next morning and saw that the house was fine. We lost a bunch of stuff in the pantry, fell on the floor, but that's about it. So then on Maxtor, the rest of it, Jim McCoy, who is an excellent leader, he founded the company with Jack Schwartz, and then he replaced Jack with Mike Warner. He decided that he wanted to have the company run by a professional manager. And so he hired George Scalise. I think he was out of Intel, but he was a semiconductor guy, and he didn't know squat about disk drives. So he was a businessman with no experience in our trade. And it didn't work too well. He was making a lot of decisions, and eventually Mike Warner left. I don't know what the circumstances were. And one day I got a call from Mike, then Jim came back and took over the company again after George Scalise kind of screwed it up. But he didn't stay very long. And so Mike called me up and said, hey, let's do a new company called Orca. So it turned out that he and a fellow named Dick Reiser had acquired the assets of Priam, and Priam had produced a disk drive, but they never got into production. And so Mike had acquired some funding from people from England. And so I was in charge of 3.5, and Bob Deerdorf was running the 5.25. And it was a very small company. But Dick Reiser had put the whole manufacturing process on a series of spreadsheets called Quattro Pro. And I took over that. And I really liked that. That was interesting. And I used that experience to greater advantage later. Mike was offered a whole factory in Berlin, or in Germany, that was idle because after the Cold War problem, there were no manufacturing. There was not very much manufacturing going on in Germany, West Germany. So unfortunately, the financing died from England, and the company folded. So that was the end of that. Then a very short stint at Toshiba. Ron Dennison gave me a call one day and said, hey, we'd like to have a heads and media guy over here at Toshiba. It was Toshiba America, not Toshiba Japan. It turns out Toshiba America out of Southern California had a demand for 3.5-inch disk drives. But Toshiba Japan didn't want to make those. They made 2.5 for their laptops, but nothing bigger. So the company had a product and was going to go. Unfortunately, it ran out of money from Toshiba America, and Japan didn't want to step in, and so the company folded after about a year or so. And then after that, I guess I went to Connor. I was recruited. It turned out Connor was just full of IBM guys, and Mike Workman had the engineering responsibility, and Dan Niedrich and Matt Foss were in his group, and they wanted me to be program manager for high-end SCSI drives. It turns out Connor had made its success on the consumer-grade drives, the little SATA drives built in Colorado, or designed in Colorado. Their claim to fame, oddly enough, and we got to use it, was John Squires had developed self-test. And he put a little Motorola processor on the circuit board of the drive and turned it into a little computer. prior to that, people had to buy test equipment, like a Guzik tester, to test the disk drive. And this invention by Squires said you didn't need to do that anymore. You could have the drive test itself. So that's what we did at Connor San Jose. We were in the high-end area, selling to people like Intel and fast and wide SCSI. So, and they test these drives 50 at a time with self-test. It was really kind of creative. So Connor San Jose was making these enterprise drives, and they're doing okay. And then all of a sudden, a guy named Tom Mitchell, he had left Seagate under some, I don't know why he left, but he left Seagate, and he had a no-compete contract for a year. A day and a year after that, he shows up at Connor. Finance and he were buddies, I guess, and he turns the business over to this guy, Tom Mitchell. And Tom was a rough guy. Very capable manufacturing guy, but a tough manager. And first thing he did was to fire Mike Workman. And so our engineering department was sort of mixed up. And then I guess about 6 months later, it turns out that Al Shugart bought Connor. And so now the new boss was Al Shugart. So he showed up one day at the Connor cafeteria and announced that you guys are now Seagate employees. And I had known Al from other companies, or from IBM mainly. And so that was okay. Al's a good guy. And so, but I had to reshuffle everything. And one of my jobs to sell off as a program manager, sell off the inventory of drives, and we did that. And we went up to Intel. I took a task force to Intel. They had it turns out the drives were very good mechanically, but the weak part was the firmware, because you had to have drives work in any environment. It had to be PS2 or Windows or Unix or any of those things. And there were some problems. And Intel had two facilities in Oregon. One made the microprocessors, the other one made systems, and that's where our drives wound up. So I took a team up there with an engineer and some laptops and some girls to do the work, and we upgraded all those drives, and so that was a success, and came back. And after that, I was transferred to customer quality. It sounds like an interesting idea. What they did is, in Seagate, the customer quality was the interface between the customers and the factory. They didn't want the customer to be calling up the engineering people and taking time and maybe getting bad advice. So we were the interface. And so I took a team from HP to Singapore to do an evaluation of our factory, and so did some field work like that. And then that was fun. Connor was an interesting company to work for. Very good people. Then what else happened at Connor? Yeah, that's about it. Then I got a call one day from Mike Warner again. And he says, "Hey, I got a new sandbox you can play in." So at Seagate, I had a good time there. And I got a call from Mike Warner again, his personal friend. And he says, "Hey, I got a new thing going, and I'd like you to join me." I said, "What is it?" "It's semiconductor packaging." "Oh, I never heard of that." And he says, "Well, I think you'll be good at it." So I went over and interviewed with Mike and with Tom DeStefano, and they hired me on as director of customer training and QA. So this was chip scale technology, which is a new thing. And basically, the size of the package was no bigger than the die itself. And you did that by having solder ball connections to the bottom of the die, which would match directly to the substrate of the finished product. And then you would reflow with heat to melt the solder ball to make all the connections. And then you had to solve the problem of thermal expansion differences. So you have solder, and you have silicon, and you have plastic stuff with the tab tape. And so the trick was you'd underflow it with filled silicone. And that was the basis of the original patents that Di Stefano had for this chip scale technology. And so it was pretty successful. We sold licenses to Sony, Intel, ST Micro in Italy, and my job was to train them. So we bring them to San Jose, spend about a week. They would bring samples of the die they wanted to get processed, and we had a prototype line, and we'd have lectures by the various people who do the tab tape design. Would give them a talk on one day, and then the solder ball placement, Jennifer Fosbury was the lady who did that, and the underfill and the reflow and testing and all those things. Each subject was a day, and then we take them out to lunch and so on. So that was pretty successful. We trained probably a dozen or so companies, and we made a movie of this for the people who couldn't come. And what else?
Before you go on, if I could interrupt you, it seems like you just described very quickly a key breakthrough in packaging, right?
Yeah.
For the listeners, it may be worthwhile for you to talk a little bit more about the details.
Oh, okay.
And what made it work successfully.
Okay. Generally, the packaging was done on tab tape, which is a polyimide tape that's good for high temperatures. So normally you can't solder to most plastics. And so the idea is you would have a die that would have solder pads on the underside that were metallized, and they were susceptible to be soldered. So what you do, you take the tab tape, which have the pattern, the layout of where you wanted the circuits to go, and then you would take the die with the matching circuits or matching positions. You'd have a robotic ball placement. You'd put the little ball, you'd put some flux on the tab tape, you'd put the little balls on the various pads, and you would place with the robot the die on the solder balls, and you'd send it through a reflow oven, and the reflow oven would melt the solder and get rid of the flux, and now you had the die stuck to the tab tape. But you still had the problem of coefficient of expansions being different, and so you would need to mitigate that, and the idea was you put something semi-rigid, which is cured silicone resin, you have to inject that into the space between the die and the tab tape. And of course, the solder ball's in the way, so you would push this material in, and with pressure, and you cook the whole thing in an autoclave to cure the silicone. And then you had a finished product. You would cut out the devices from the tab tape. We had tab tape made mostly in Japan by Shindo and some other company, I forget who it was. So it was quite successful. We had a number of interesting applications. One was the military. It was very durable, this configuration, as opposed to a normal circuit board. And so they put one of our packages in an artillery shell and shot the thing into a haystack or something, and it worked. The circuitry was fine after being fired from a cannon. And I said, what purpose would you? Why would you want to make an intelligent artillery shell? I never got a straight answer, but I think the answer was that there was enough intelligence in the artillery shell to know when to blow up. Do you blow up when you hit the wall, or do you go through the wall and blow up inside? So there was probably something like that going on. Then there was also interest in mortar shells that would decide when to blow up when you don't want to necessarily hit the ground. Maybe you want to blow up 10 feet off the ground. And so that was considered as things wound down a bit. Again, what happened with Tessera was other competitors got into the game, and some of the interest kind of died off in our thing. And so the company was looking at things like this military project. We also were involved with a cochlear implant, a little circuit that would go inside the person's body and be an implant for hearing. Our VP of Chris Pickett, said interesting technology and a good application, but he didn't want to do it because of the liability. He said personal liability could be outrageous. You could cost you millions, and in a personal injury case, they would sue everybody inside, including Tessera. So he put the squash on that. And so the company started to kind of shrivel up. Mike Warner left. I'm not sure why. They brought in another guy, Nick Colella. He was from the Lawrence Livermore National Lab, and he was interested in some of these government projects. The problem with the government projects, they were cost plus. There was no big future to it. You just get paid for doing research. And the medical thing was too dangerous. And so eventually what happened is I left full-time employment, but they retained me as a consultant to do cost modeling. And they split the company into two pieces. One was called something, I've forgotten what the two names are now. But one was pursuing intellectual property, the other was a software company. So Tessera is no more. It's two pieces now. ADEMA and I forget what the other one is. But in its heyday, they had brought a couple of things. They had a publication. A guy named Vern Solberg did this. Chip Scale Review. This came out every month.
Yeah, hold it a little higher so it shows up in the, wow, yeah.
So this came out every month and was sent to all of our customers, and was kind of the publication for that kind of product. So that was interesting. Mike and I were asked to write a part of this book, and so we wrote a chapter in this textbook.
Can you read the title of it?
I can't quite see it upside down.
Yeah. Foldable, flex, and thin silicon multi-chip packaging technology. That's quite a mouthful.
Yes, it is. And we have a whole chapter in this thing. I'd like to donate that to the museum if they want it. So anyway, the company wound up getting broken into pieces, and I stayed on for a couple of years, mainly as a consultant doing expert witness stuff, because an intellectual property company is bound to be sued by somebody, and so there were lawsuits about this or that, and so I was asked to come in, and I did that. But at about the same time, I got a call from Jim Smith, who's a friend of mine. He was in the Dr. Jim Smith. He was a chemist who ran one of our labs at Seagate, and he said, "Hey, I have a good friend over at City College. She's the dean of math and science, and I think you'd be a good fit. So go over and talk to him." So I did. Went over and talked to Leandra Martin, and they had a little kind of kangaroo court of all the instructors around a table, and I was back and forth conversation, being grilled. And so it went on for about an hour, and finally they said, okay. And one of the guys who became kind of a mentor, John Song, he says, "Hey, let's take a tour." So he takes me a tour of campus, says, "Do you give tours to all the people who apply?" He says, "No, you're hired. You just don't know it yet." So I wound up being hired as a part-time instructor in chemistry department, which I thoroughly enjoyed. And I brought some interesting things to the party. It turns out that we were using a commercial manual, lab manual, by somebody named Sarah Selfie, but the manual was incomplete, didn't cover everything we wanted, and it had errors in it. And we had not much cooperation from the publisher. So I was talking with Madeline, our lead chemistry person for 32A, of course, And he said, let's write our own manual. And we could do that, and it'll publish it in-house. So we did. I wrote most of the experiments, along with her, Madeline Adamczewski, and a fellow named Sami Ibrahim from Egypt, and another fellow, Lee Wilson, who managed the publication process. So that was successful, and we developed a manual, and it was used. It still is used, I think. Then COVID hit, and so can't do a lab with COVID. You can't go in the building. So what are we going to do? So I said, hey, let's make videos of instructors doing the experiments, and then we can publish the videos and give them to the students, and they can see the experiment. They can't do it, but at least they can see it being done. So that's what we did. And we shot about 20 videos, and I personally did 4 or 5 of them. So it was a nice experiment. Then we had something called PLTL, which was peer led team learning. And the whole idea was that people taking the courses would go typically to a 1-hour lecture a couple times a week, and then a lab either once or twice a week. But a lot of times it wasn't really adequate. It's not very hands-on or person-to-person because the lectures might be 50 people. So this PLTL was a group-led thing. And so small groups, maybe 5 or 10 at the max, would be hosted by a prior student who did well in the course with a faculty advisor, and that was me in some cases. And so in general, the people who did that, and it was voluntary, it wasn't required, did better in the course. So it was a successful program. And it became international. PLTLIS had people from England doing the same thing. And we had conferences, worldwide conferences, twice in Texas and once in San Jose. So I think it was unusual for a community college to be doing all this stuff at the university level, which was fun. And then in the experiments, I did some stuff that was creative. The physics department had bought a bunch of stuff for nuclear experiments. They bought it from Oak Ridge, Tennessee company, which is where the national nuclear site is. And so it was nice. It had Geiger counters, it had shields, it had all kinds of samples. And so I created an experiment. Here again, the idea was that our students in 32A were medical students going into the medical field. And nuclear medicine is a big deal today. I had a personal experience at Kaiser where I had some heart issue, and they inject you with technetium-99, which has about a 4-hour half-life. And once the stuff is circulating in you, you stand up to a sensor, and they can see the veins. They can see where the blood flow is. So it's kind of cool. And so I wound up having a stent placed in. But I thought it was interesting for the students to be exposed to all that stuff. So we ran this experiment, and it turns out Brazil nuts tend to collect radium. No, they collect, it was radium. And tobacco is slightly radioactive, and bananas have potassium-40. So we would show all these things to the students, and smoke detectors have americium, that's a radioactive material in them. So that was a unique, there was a half-life experiment where something dies off in 2 minutes so you can see it die off. So I thought that was pretty cool, and we did that experiment. And then I did one on poisons. Here again, the medical students would enjoy this. It turned out that we had fentanyl coming in as a dangerous material. So we studied all the different things that you could get hurt with, the relative dangers of cocaine and heroin and those kind of drugs, but also household things like bleach. There was a lady in Pakistan who drank a quart of Clorox to kill herself to avoid an arranged marriage. And so you can get killed with stuff around the house. And so anyway, the lecturer and lab had all kinds of data on different things. Also, the Russians were poisoning people in various ways with ricin, You probably heard about that. The guy with the umbrella gun injected an ex-KGB guy on a bridge in London, and he died a few days later. And then another fellow, ex-KGB guy, also in London, he had lunch with his friends, so-called, and they slipped him a dose of polonium-210, I think it was, and he died in a few weeks. So Russians have some nasty ways of killing people. And so I'm wondering, why would you do such a bizarre thing? And the answer is it gets a lot of press, and then the other guys who might want to defect say, hey, I don't want to go through that, so I better keep my mouth shut. So I think it was for advertising as much as anything else. So anyway, that course, we did the videos, and we did the PLT, and some other stuff I don't recall right away. But it was a lot of fun. I enjoyed it and did that from 2005 to 2023. So over about 18 years teaching part-time. It was not a full-time job. It was kind of on demand. I did all the courses that are inorganic, did Chem 1A, Chem 32A, Chem 15, lectures and labs, and did a lab for organic thing. We made benzocaine. So that was fun. And so I've had a fun career.
Was that perhaps the longest tenure you had in a job?
Yeah, it
right?
was.
The one at City College?
Yeah. Well, because it was part-time. So,
but still.
But part-time really means almost full-time, because it takes a long time to prepare the lectures, to prepare the lab stuff and all that. So, and then grade all the papers, the final exams, and all that stuff. But it was fun. I enjoyed the people. One of our friends at the college was Sami Ibrahim, and he's from Egypt. And one day he says, "Hey, how would you like to go to Egypt?" And he says, "I'm going to take about 40 or 50 people on a tour of Egypt." He said, "Hey, I'm game." So my wife and I signed up, and we had a wonderful time going to Egypt. Saw Luxor, and got to walk inside the pyramids, and saw all those things. So that was another kind of interesting aspect of City College.
An interesting fringe benefit, right?
Yeah, fringe benefit, yeah.
You talked a lot about radioactive materials in your most recent.
Oh yeah, we didn't talk about that.
Did you also apply that knowledge in the packaging world?
Yes, indirectly. It turned out that I forget the year, but both Intel and IBM had soft error rate problems in some of their chips, probably memory chips, and finally it was traced to alpha rays. It turned out that alpha particles have high energy, but they're absorbed very quickly in the air. But if you place the radioactive material next to a die, like a solder ball, well, that was another problem we can discuss. But it turned out that there were two sources of the problem. One was, I think it was IBM, was using water from a river that was downstream of some mine that was mining carnotite or radioactive material. So somehow radioactive particles were getting into their wash water or something like that. And so IBM tracked it down to that. Now these errors were soft errors. You would rewrite and it would be fine. It just it was a transient error problem. In the case of the packaging, it was the silica. They used natural silica, Dow Corning did. And natural silica from the ground has trace elements of all kinds of stuff. And all it would take, it'd be a tiny bit because it's right next to the die. And so it turned out they had to abandon, because of this radiation contamination, they had to abandon natural silica and make it synthetically. And then it was okay. And then the other problem was solder. Solder, it turns out, is eutectic solder, 63% tin and 37% lead. And lead-210 is radioactive. Now, it's a very small amount, but it turns out it also is an alpha ray emitter. And so you can't put a solder ball next to a die and then with radioactive lead in it and expect a good result. So one solution was they went out and found old lead. It turns out that lead-210, the radioactive material, has a half-life of 22 years. So after about 10 half-lives, it's pretty much gone. And so they went out collecting old Roman pipes and things made a couple hundred years ago, and that was pretty much free of lead-210, and then made solder out of that. And then the Russians were making isotopically pure lead, the way that you separate uranium, but except this was lead. So yes, those were two practical problems, or three actually, the wash water, the silica, and the solder balls. So, and they had conferences about alpha radiation, and I went to every one for several years. It kind of died off after a while. But that was very interesting stuff. I like that. During summers at Berkeley, I would take courses in things that were fun. And I took one course in nuclear medicine, and so that sort of fit in with all this.
It's fascinating. I don't think I know anyone else that's had as varied a career as you did in terms of number of projects and number of companies that you worked in. It's fascinating. Along the way, did you get unique recognition for your contributions? Did you get any awards? Did you?
Oh, yeah. I brought, there's 3 patents that I got co-authored at Tessera in the book. I got, then there was all the ANSI stuff. We haven't talked about that yet. Maybe that's appropriate. Starting at Caelus, there was a thing formed called, CBMA, Computer Business Equipment Manufacturers Association, was the working arm of ANSI, American National Standards Institute. And I did bring, for people who haven't seen, here's a ANSI standard. And so what we did is this group originally was under Paul Green from CDC. I've got several of these. I'll donate these to the museum because I have no use for them anymore. We would standardize the DISPECs, and the whole idea that ANSI was pursuing was user data interchange. They wanted to make sure that any DISPEC written by anybody on say, an IBM machine could be read on a CDC machine or vice versa. So the whole idea was user data interchange to protect the transferability of data. And so we had meetings a couple times a year, and I attended those. And then Paul Green eventually left. I don't know if he left the company or what, but he quit being the chairman, and I was elected chairman of X3B7, which was the group doing this. And so I had a lot of experience from IBM and other places writing specs. And so we wrote specs for the 1316 DISPAC, the 2316 DISPAC, 3330, 5440, 2315. The only non-IBM product that was standardized was 2 things. One was a CDC SMD storage module, and then the other was the Sony floppy disk. So anyway, we had meetings a few times a year and generated all these documents, and they're all available. You can go online to ANSI, and they'll give you a big laundry list of documents. You can order them. They're still available. So we did that for a number of years. And then it turns out that in Europe, they have something called ECMA, European Computer Manufacturers Association. And they're doing a similar thing around Europe. And then once a year, they have something called ISO, International Standards Organization. I brought one of those just to show people. And what happened here is, here's an ISO. what happens here is that now the whole world gets together to do the same thing, to make sure that everything is compatible, so that a disk drive made in Russia can read a disk pack made in the USA and so on. So we had meetings all over the place. London was one, Paris, Milan, and and West Germany. These were Cold War times, and West Germany was memorable. You had to fly in, and it's surrounded by Eastern Germany. And so we had our meeting, and then we decided to go through Checkpoint Charlie and visit East Germany. And so we did, and you have to take your passport with a 10 Westmark bill, and then they give you a 10 Eastmark, which is worth a lot less, but it was cheaper over there. So we went through Checkpoint Charlie, had dinner, and it was desolate. The West was bustling, the Eastern Germany was just desolate, just guards running around with machine guns. So we had a nice dinner and came back. So we went to a number of meetings, went to Japan, loved Japan, and I had gone there in Caelus days, we were selling discs to Hitachi and dealing with customers over there. So I got a lot of traveling done with ISO. And then one day, a guy from National Bureau of Standards, Phil Johnson, I think it was, he said, "Hey, there's a thing with Department of Commerce. You ought to join us. I'll send an invitation." So this was an invited participation in setting export restrictions or advising. We didn't have the power to do anything legally, but we were just advisors to the Department of Commerce. So a few times a year we'd go to Washington, D.C. I had to have a lockbox in Los Gatos with an approved lock and to keep classified documents and that kind of thing. So we were asked to review documents and send them back. Then once we had these meetings, it was about half government and half industry. I think the whole group was probably 40 or 50, and about 20 of us were from industry. I remember a Tektronix guy was there. And what they would do, the whole object of this was, you don't want to sell something to the Russians that'll come back to guide a missile to hit you. So we're trying to protect yourself by restricting dangerous things that could wind up hurting you. Infomag, for example, was selling heads to Switzerland, but they wound up in Bulgaria. So Commerce had to shut them down, said, "Hey, you can't do that." In our case, we didn't do anything like that. We had these meetings. One guy from Tektronix got up and he said, "Hey, you guys are restricting our equipment too much. I was in Bulgaria and I found our stuff all over the place." And I asked them how much they paid, and they said, "We paid so much." He said, "Well, that's the same price in the States." So he says, one possibility, Department of Commerce, is when the black market price gets to list price, then shouldn't be controlled anymore. That was not a popular opinion. So anyway, it was interesting, and I did that for 2 terms, and then Bruce Colgrove took over. So that was the ANSI stuff. We went to have good turnout. The government always kind of wanted to go to government locations, Bethesda, Maryland, or Washington, D.C., and we found that we got a bigger turnout if we went to Las Vegas or Orlando, places like that. So we did. Tom Ferrara, he was our helper, and he organized all these places. One of the memorable trips was we went to lots of memorable trips. New Orleans during Mardi Gras. We went to Lake Tahoe, and floppy disks were being discussed. It was a 2-day thing. We would discuss rigid disks on first day and then floppy disks on the second day. Eventually, we turned the floppy disk over to Jim Barnes as a separate X3B8 committee. And this was the time when we decided on what the national standard was going to be for the 3¼ floppy disk. And it turned out that there were 3 contenders. Dyson had essentially just a size-reduced 5¼ nothing exciting there. IBM had proposed a 4-inch device, and then Sony had the little 3.5-inch hard shell floppy disk. And so with IBM during the meeting, they obviously had done a lot of evaluation. They said, the guy got up and said that we are going to withdraw our submission and go with the the Sony proposal. So we called a break, and everybody ran to the phone to call home. And then when we got back, Dick Preisser from Honeywell says, "Oh, I vote that we adopt Sony." And the vote was almost unanimous, and that became then the U.S. national standard. So, what else? So we're talking about commerce.
You had, I'm sure you made some preparatory notes. You want to refer to them to see if you missed anything?
I didn't bring my glasses. I can't see them anyway. you got the script there, so.
Yeah, well, I don't.
Did you miss anything?
Well, you told some interesting vignettes, like, do you remember some bartering of food products for products, or your wife had experience with?
Yeah, that's now you're down to the fun stuff. Yeah, some of the fun stuff. One was I called military intelligence, and that was one day at IBM, George Santana came up to me and said, "Hey, we had a military request. If we erase a disk pack, is there any possibility through any technology that the data can be recovered?" And I said, "Well, there's off-track stuff, but you've thought of that. I can't think of anything." And he said, "I can't either." And so a couple of weeks later, I ran into George in the hall and I said, "Hey, George, whatever happened to that military disk pack problem?" "Oh," I said, "they burned the disk pack." They didn't want to take any chances. And then he smiled and he said, "Then they burned the heads too." They didn't want any bad data going through those heads.
Yeah, interesting.
So it was very comical. And then what else? Then one day at Maxtor, the Air Force came in. And they said, "We want to put a disk drive in an airplane. And how high can we fly before the heads don't work? Because they require an air cushion." And so I said, "I don't know." So we got Ron Dennison down. He's a tribologist and knows about Reynolds equations and stuff. And so he said, "Well, yeah, you run out of air at some point. How high can you fly? How high do you want to go?" We said, "I'm sorry, it's a military secret. We can't tell you." And so he said, "Well, I can't answer." He says, "You best put it in a sealed box, and then you can fly it anywhere you want." So that was a fun one. And then the thing about the canned hams, my wife was working for, what was it? McDonnell Douglas, I think, was in Long Beach when we were in Southern California. She had a fun job. She was executive secretary, and she got to meet the astronauts and various people. And one day she comes home with this canned ham. Oh, beautiful thing. And so we had it for dinner, and she said, "That's really nice. Where'd you get that?" "Oh, at the company store." "Why are they selling hams? What's that all about?" He says, "Well, they sell airplanes, but some countries don't have enough money to buy an airplane. So they took it out in trade. So part cash, part hams." So that was, I thought, funny. What else? There was a submarine disk drive. The military wanted to make a disk pack immune to salt water, or to salt air. And it turned out the disks were okay because they were coated, and the plastic in the disk pack was okay. And I guess they did whatever they had to do for the drive itself. And so the only suspect was the hub. And so I was given the job, being a junior engineer. You're going to take it around to all these places. And first they zincated it. You're going to coat it with zinc. Then the next operation, they were going to iodine it. They dissolved the zinc that the first guy put on. So it went through this silly process, and then it was built and given to the military, and I guess they were happy with it.
Well, the other aspect of your background is you might be able to predict what the future will be like, and based on decades of experience here, what's your outlook for the future of data storage and memory and semiconductor packaging? You know, those are the areas you spend.
Well, I'm constantly amazed at the density of packaging, and through the hammer use of heat-assisted recording to lower the coercivity so you can write to it is amazing. That increase. Then the shingles process, which layers the tracks. And there's an incredible amount of capacity. Eventually, at some point, you're going to run out of material. You know, some of these techniques will wind up maybe not quite molecular, but certainly not a lot of material to record the data. So I don't know how far they can push magnetic recording, but there's other things that are going on. There's something called the Superman memory. I don't know a whole lot about it, except that it's in a crystal. You take an amorphous quartz crystal, and you use lasers to penetrate the crystal and write layers of data, kind of like stacks of CDs, and it makes pits with the lasers. I don't know how that's done or how you read the data back. The advantage is that you can then since quartz is extremely durable and long-lasting, you have an infinitely stable memory. So I think it's been demonstrated, but I don't think it'll ever be something of use in a laptop, for example. So what else is going on? In packaging, I think it just depends on the density of the products that are being produced. I don't have any real comments on the packaging aspect of it. It's more in the semiconductor part. How many devices can you put? Flash memory is incredibly dense nowadays. You can buy 100 gigabyte little thumb drives that fit in your pocket. So that's incredible. I asked an Intel guy once at one of the IDEMA meetings, you're writing now multi-level flash drives. Isn't that less reliable? And he says, yes, that's true. You know, there's always a chance of problems. The more complicated it gets, and he said it certainly is an issue. As you get into very high densities, the reliability is going to suffer. And that's where things like error correction code comes in. I've read that optical disks and flash memory wouldn't even be practical without error correction. And the controller in a little flash drive directs traffic and puts the data into unused cells and circulates the data around so we don't wear out any particular cell too fast. And I once had an experience. We were on a trip to Alaska, a vacation trip, and my flash drive quit recording. I could read the stuff, but I couldn't record it anymore. So I sent it back to SanDisk, and they gave me another one. But I think and it was a high density at the time. So I think there's some risk as we keep increasing the density that the reliability is going to catch up with us. And if the error correction can't keep up, then you have a dead memory. There's other technologies that are coming out. Nobody seems to think much of this, but most of the recording technologies today are physical. You know, phase change is a physical thing. Magnetic recording is a physical thing. HP, Stan Williams, came up with these memristors, which for the first time is a chemical change. They changed the surface of titanium dioxide into conductive or not conductive. And he was going to make a RAM out of that. And I guess they did internally, but I've never heard anything about that since then. It's a different technology. It's chemical rather than physical. But maybe there's some hope there in the future. Other than that, I can't think of anything that I can contribute.
Well, like you said, the advances throughout your career, you think back as to what the density of information was when you started. The Ramac drive was developed shortly before you joined IBM, right?
Yeah, well, it was the Ramac drive was built in 99 Notre Dame by Ray Johnson, and it held all of 5 megabytes. That's one Beatles song on that great big thing the size of a refrigerator. But the advances were amazing. When I got to IBM, they were still making 24-inch disk drives, the 1301, 1302, but they were much higher capacity. There's some other funny stories about those. One day we were told that, I think it was the 1301, it was a 24-inch disk drive in any case, had been flooded. It turned out Volkswagen of America had a headquarters in Florida, and they had the data center in the basement. And along came a hurricane, flooded the basement, and the poor disk drive was submerged in salt water. And their backup was stacks of cards, and of course those were wasted, the waterlogged cards. So they were in a pickle. And so they sent the whole drive back to San Jose, and it was taken apart in Building 5, and then Herb Pugh and I took the disks and very carefully polished the surface to get rid of any corrosion that might have been, and glide tested to make sure that heads would fly. And then the disks were given back to manufacturing, and they took all the data off somehow and put it onto a new drive and sold it and shipped Volkswagen a brand new 1301 or whatever it was with all their data intact, which is an incredible story. I thought that was amazing.
Well, I think you were recently at one of our meetings where they described the latest disk drives, 3.5-inch drives, have 40 terabytes of capacity.
It's amazing.
What a contrast with the 5 megabytes of Ramac. And I think the bit density in those drives is 1.9 terabits per square inch. That was the number I remember from our meeting.
It boggles the mind. It's amazing. We've gone so far so fast. I don't know where it's going to wind up. Oh, another funny story was in the 1301s and 1302s. One day we were shown a head. They had a dual actuator in this machine, and the head was full of sticky stringers. What the hell's that? And so it was taken to the lab, and they analyzed it, and it says, it's glue. What the hell's glue doing there? And so it turned out that when they assembled the 24-inch drives, the disks are pretty heavy, and the in-hub motor was pretty strong. And so what they did is they put a layer of glue on the disk, then a spacer ring, more glue, another disk, and like that. And it turned out the vendor had changed the recipe. It was Dewey Elmy shoe glue. And so what happened is the motor heated up and spun out the glue over all the heads. So that was crazy stuff.
Well, I don't know, Bill. You've had a wonderful, imagine you were part of this progress from essentially the Ramac days to today, right?
Yeah, pretty much.
And you stayed active in the Computer History Museum, right?
Yeah, I've been out of the actual disk drive arena for quite some time. Went teaching. I kept up as I could, and I go to the History Museum meetings, and I'm still talking with people like Ron Dennison and so on. So I'm aware of what's going on. I'm just kind of blown away by the progress. And some techniques I thought were fairly impractical, like filling a drive with helium to reduce the air drag. The helium just leaks out of everything. It leaks through metal. So I don't know how you seal a drive full of helium, but they're doing it.
Yeah, that's amazing.
That's surprising to me.
Well, looking back now at your experience, what advice would you give a young engineer or scientist who's might be interested in entering this field?
I think I thought about that, and I think the biggest contributions have been made by people who have two skills. For example, Gordon Moore at Intel was a chemist, and he helped invent the semiconductor industry, or the microprocessor industry. So, and you can find examples of that all over the place. So I would say follow your heart and go to the field that you like, but find some other field that can join with the field you like. And lots of examples, physics and chemistry, physics and biology, computer science and biology. One thing I've always been fond of and never saw it much being done is, I don't know if you knew Marcel Vogel.
Yeah, I did. Mm-hmm.
Yeah, so we became friends, and he was experimenting with communication between plants. And he was in Building 25 and making big photographs, but on his own time, he was doing this investigation work. And I was over at his house in the Rose Garden, and he'd have a philodendron wired up with a lie detector. A guy named Maxtor had invented a lie detector, and then needles that move back and forth. So it's kind of like you see in the movies. And so he wired up one plant, and then in another room, he would hold a match under the leaf of another plant, and then the plant that was wired knew about it. So there was something going on, and he did a TV thing, local TV, and I went to that and showed it. And then there was a book called Iron Curtain Experiments on Telepathy and so on. So there's something there. I don't know how we'll ever develop it, or even if it can be developed, but there have been movies. I remember one movie was a thought-controlled airplane and so on. So I think that's a field that really is deserving of some work, but I haven't seen anything done since the Marcel Vogel days. When I followed Marcel around, he wound up moving from Building 25 to ASDD and I think Los Gatos, and working on some tape stuff. You're a very fun guy, interesting guy.
Well, I offer my congratulations to you for what's clearly been a very interesting career and contributions in many, many areas.
Oh, it's been a fun ride. I couldn't have been more lucky. I just very fortunate. IBM was an absolutely wonderful experience, and that led to all these other things. So it's been a fun ride.